everyone, and welcome to another video in my mini-series on the strangeness of sharks. Today I am going to be talking about crypsis in sharks. Crypsis is the ability of an animal to hide itself from other animals, and in sharks it can serve a few purposes. It could be used to hide from a predator, or it could be used to hide from prey in order to ambush them. This can be done visually, olfactorily, or auditorily, but I am going to be focusing on visual crypsis for this video. This means I am going to be focusing on camouflage, counter shading, and luminescence. Having patterned skin, scales, feathers, or fur is a really common method of camouflage. These patterns allow an animal to blend into their environment, which can either be used to hide from predators or can be incorporated into hunting prey. Zebra sharks have a striped pattern when they are young, which they use to hide in corals and substrate from their predators. It actually works so well that often young zebra sharks aren't seen in the wild. As these sharks mature, their stripes are lost and are replaced by spots. The adults and juveniles are quite significantly different, so it's understandable why, despite them being in just different stages of life, scientists actually initially classed them as two different types of shark. It's also why, to this day, that adult zebra sharks are often misinterpreted as leopard sharks. Though it does make sense why that might happen, because who would expect a zebra shark to be spotty? A shark which does retain its camouflage throughout its life is the wobbegong sharks, a family of sharks made up of 12 extant species. The common name of the group, wobbegong, is believed to mean shaggy beard, which comes from the dermal lobes that extend from its face. These structures, along with the coloration and patterns of the wobbegong shark, make it really effective at blending into its coral and rocky environments where it lives. However, these sharks are not hiding themselves from predators. Instead, the wobbegong shark is using it to hide from prey, and they are actually really excellent ambush predators. Those dermal lobes, which resemble coral, can bait unsuspecting fish for the shark to catch. So from the zebra shark to the wobbegong, you can see how camouflage can be achieved in different ways and for different purposes. Counter shading is a form of crypsis seen in many different species of shark. It's basically when the side which receives the most amount of light is the darkest. This generally means for sharks that the darker side is the ventral or top side, whilst the lighter side is the dorsal or underside. Having a body colour like this is advantageous because it allows them to blend into their environment better. Basically, when something is swimming above it and looking down on the shark, it blends into the darker water beneath, whilst if something is underneath and looking up, it blends into the sunlight coming into the water. The coloration improves the ability of these sharks to ambush prey, and it's seen in many species including the great white shark, black-tip reef sharks, and the blue shark. Counter shading is actually such an effective morphological adaptation that it's seen in many other different groups of animals as well. It's also seen in cetaceans, such as in the killer whale and in the white-striped dolphins, and it's also seen in all extant species of penguins, from the chinstrap to the rockhopper, from the emperor to the fairy. Many terrestrial species also show counter shading as well, such as in deer or birds or even the grey squirrel. However, the contrast in colour is more predominantly seen in marine species, with some of those species I previously mentioned tending to have dark blue or black backs and a white belly, whilst the terrestrial species I mentioned tend to have much paler body colours, often varying in shades of brown. Counter shading is therefore seen as generally more effective in marine environments, and this is because light is scattered much more evenly in water. The lack of significant shadowing in marine environments means that they can have a much more contrasted counter shading, as they are not going to be encountering any sort of environments where the dark colours or the white colours really stand out. And this is likely why counter shading is seen in so many different marine predators. Luminescence, when seen in animals, is the ability to create light through chemical reaction. Although it is often used in communication, it is also used to avoid predators and ambush prey. When animals use luminescence to replicate the surrounding light levels of their environment, this is known as counter-illumination. Counter-illumination allows them to hide their silhouette and camouflage themselves in their environment. It has been documented in a wide range of taxa, including crustaceans, cephalopods, bony fish, and even in some sharks. Photophores, the organs which allow marine organisms to emit light, are relatively simple in sharks. Because of this, scientists didn't initially know if counter-illumination was something sharks are capable of, as it requires the ability to read the ambient levels of light and adjust their luminescence accordingly. However, counter-illumination has now been studied and noticed in a couple of different shark species, including the velvet belly lantern shark and the cookie-cutter shark, which I've actually mentioned in one of my other videos before. Sharks ultimately prove time and time again to be utterly strange creatures. Their behaviours, morphologies and physiologies are incredibly fascinating, but still so much mystery surrounds them. With their lives in the open ocean, sharks are enigmatic, and scientists are still working hard to understand the unique nature of this marvellous branch of life. I hope that you've enjoyed this video and the whole mini-series on the strangeness of sharks. For the time being, this is it for the mini-series. I might return to do some more videos on it later, but this is it for now. I'll still be releasing videos twice a week on a wide range of biological topics, so if you have any requests, feel free to leave them down in the comments below. In the meantime, feel free to check out any of my other videos and don't forget to like and subscribe if you want to learn more.